everyone, welcome to another day of fun algorithms. Let me just make sure my screen is working as well. Okay, let's start out with some Code Wars. Classic, but always good. So, okay, we're gonna do 8. Okay. So you're gonna write a function that takes in a list of strings, and you're gonna return a filter list containing the same element, but with the geese removed. So the geese are any strings in the following array which is pre-populated in your solution. So for example, if this array were passed as an argument, your function would just return the following. Like Bill. Okay, so essentially, let's go ahead. Don't mind me, 2 in 1 with a little bit of steps and also doing this, so yeah. Okay, let's figure this out. So I'm going to do this in Python. So let's definitely always talk about our inputs and outputs as well. So we're going to receive in a list of birds, a list of string of birds, and then we need to return a filter list where all of the geese animals are removed. So if I have an array of I'm horrible at these names. We'll do like pig. We'll do like pilgrim. We'll do penguin. So in here, what I expect to see back is just a pig, and I'm gonna see a return the penguin, because essentially what it's saying here is that, hey, we want everything to be returned back except the names that are listed from the geese list. So we can go ahead. The way I would think about this, I would definitely initialize an empty array, an empty list, and then I would iterate through all the names of the bird. I would iterate through all of the bird names in the bird list. I would check to see if their name is in geese list. Check if their name is not in geese list, then add to empty list. Otherwise, if you are a name that belongs in the geese list, we're just not gonna do anything with you. Or you can argue, and then we'll just go ahead and do that. So then we're just going to head and return the list back. But I know that I could the fact that the return output is asking for a list back, I think I could definitely use a list comprehension. And I would say that return name of bird, if bird is not in the geese list. That's what I would say. Return name if name is not in I would say if name not in geese, return name for name in birds if name not in geese. I hope that was easy to read. If not, feel free to let me know. I can definitely decipher that a little bit more for you. I know that list comprehensions are like a new concept. They were a new concept for me because learning JavaScript, list comprehension isn't a thing in JavaScript, so it took me a while to get used to it. So yeah, this is what I would say. Time-wise of doing this is O of n, because we have to iterate through n amount of birds, or n amount of name of birds, n amount of the name in the birds list, and then space-wise, it will definitely be O of n for each name that we add in. For each name that we add in, what's the word I'm saying? So it's gonna be O of n for each name that we add into our output list that is not in the geese list. Yeah. Sure didn't. Okay. We are in, happy June 1st. Isn't that crazy that we're in June 1st already? It's crazy. June 2025, baby. Algo.py. New terminal. But I do get add -m, add it in algo, push. Okay. Cool. Okay. Oh, the bird is a lot better than what I was saying for the naming convention of this. I see. Yeah, I did think about using the dot filter. It's not a dot filter. I did think about using the filter function, but then I remembered that I could just go ahead and use a list comprehension instead. So I went ahead and did that. Cause yeah, with the filter, as you can see, you'll have to create a lambda function. And a lambda function is essentially a very specific function. It's like a one-off function to do something else. So yeah, versus filter. Okay. Let's do A7. Can you believe it? It's already Sunday. It's so crazy how the time goes. Okay, we're gonna find the stray number. So you're given an odd length integer in which all of them are the same except for one number. So you're gonna complete the method which accepts such an array and returns that single different number. So the input array will always be valid. So it'll always be an odd length number. Hi, hello, Ghost Magic. Hope you're having a great Sunday thus far. Do I? Sorry, creeping on you a little bit there. I feel like I've seen your username before. Have I seen you somewhere before? Okay, so let's go ahead and work on this. Okay, so what we're gonna do, so let's talk about our inputs and outputs. So we're gonna receive a list of integers. As of the moment, they seem like they could be positive. They're all positive, but there's nothing in here that states that they can't be negative either. I see. Ghost Magic. I feel like I've seen you on other social media, unless I'm wrong. So, yeah, I'm doing well. Thank you. Thank you for asking. Do you do algorithms yourself, Ghost Magic? So we're going to receive a list of integers. We want to return an integer that is the odd one out. Okay, so you're given an odd length in which all of them are the same except for one number. Okay, sometimes like in my head, the example that's coming in my head is 3, 3, and then we have a 2 and a 2. So we know for sure that our input array will always be an odd length. But my concern is that, okay, but we know for sure that because in my head I was thinking, what if I wanted to make sure I understood the constraints, because it seems like sometimes, so we know for sure this is an odd length. Oh, I see. Hopefully you're not working today on this Sunday. It's a nice day. It's a really nice day. So yeah, I wanted to understand the constraints better too, because I know that this is an odd length of integers, but if we have 3 3s, 2 2s, is that something I'm going to anticipate to see for the input? But based off of what they described here, in which all of them are the same except for one single number, that rules out that that won't happen. For this example, it won't happen. So yeah, so we're going to say the odd one out here that should be returned is 2. 2. So the way to do that is, the way I'm thinking in my head right now, I was thinking that we're going to do like a frequency counter pattern. So we're going to iterate through, count each one of them to see if, iterate through all the numbers in the list. Check which number has a count of 1, that we know that it only popped up once. It showed up once. They return the num. But that would mean, because I was trying to think like, if we go through and we iterate through all of them. So say for instance we're here, if we check to see if it only has a count of 1, can we exit the loop early and just return that 3? But no, we can't do that, because as you can see in this example, we actually have to iterate through each and every individual elements that are listed here, because my 2 that only has a count of 1 occurs at the end, so we definitely still have to do an O of n operation. I was trying to think to see if is there any constant way of doing it, but then it doesn't seem like it. It seems like all of it will be like a O of n operation. So for every input, we have to do the same amount of work. Yeah, so we're gonna do that. But that would mean I need a dictionary. Really? Okay, let me think about that, because I was thinking, even with my example goes magic, you think we can do that though? I think we can exit early, but not on first, because the only way to, because like if you look at the example here, we can't really exit early until we reach that last 2 though, right? So that would mean we have to go through each input. So that would be O of n time operation, right? Let me know what your thoughts are. I definitely wanna, talk about it. So just to make sure, clarify, and see it from your perspective. So we're going to iterate through all the numbers in the list. I'm actually gonna, at first I thought we could do this with a count and just ignore the dictionary method. But I will need to do a dictionary. So I am going to, first and foremost, initialize an empty dictionary. I'm going to iterate through all the numbers. This will come later. I am going to increment the count that we see for each value. So we're going to check which value has a count of 1 and return the num. Yes, other examples can be a little easier. I would anticipate like an example like this or something Ghost Magic to be a little bit easier. That's what I'm thinking. So, yeah. Okay, so dictionary is equal to this. We're going to initialize it to an empty dictionary at the moment. We're going to say that for num in R, dictionary of the num, the value of it is either equal to dictionary.get either the num, or if it's never been seen before in the dictionary, it will get initialized to 0. And then while we do that, we are going to say that, and then if it's been seen before, we're going to head and say increment the count. So now, okay, let me think this through. Let me finish this thought. Let me finish this thought. Now we're going to go ahead and iterate through. For value in dictionary, if dictionary of the value is equal to 1, then we're going to return the key. Is that the right way to write it? Key value. No, dictionary dot items. So that way I can get, I believe dot items will give me the key and the value. That way I can say, hey, we're just going to return the key. Let me test it. I'm so positive that's right. Okay, dictionary dot value is equal to 1. I don't think I need to do parentheses. Parentheses. I don't think I need to do that. Oh no, I need to destructure it out like this. No, it hates it. Okay. Okay, let me read what it says. Okay. So the key error is 6. If the dictionary of the key is equal to 1, then we're gonna return. That's my fault. Dictionary of the key. So basically, I want to look at the value of this key. Then I want to test this. I don't think I need to destructure it then, because if key already does that, I can okay, no, because I believe we need key value because I'm looking for dictionary dot items. But okay, so I want to talk about the time complexity of this. So I'm doing a for loop here, and I'm doing another for loop here. So technically, I am doing 2n because this for loop is not waiting for this for loop. Otherwise, it would be O of n squared. But since this for loop is independent of this other for loop, it is O of 2n. But with the big O notation, we don't care about constants. So we can say that it's O of n overall. And I am just trying to think. I like to look at my code. Sorry, let me finish space. Space is O of 1 because at the end of the day, we're just returning one integer. Wait. Despite just return, I take back my words, because despite just returning one integer, we're actually keeping that dictionary in place. We're actually creating that dictionary. So I am actually gonna say it's O of n. For n to be stored, n is the integers. For n integers to be stored in the dictionary. Okay, but if I look at my example, your tulips have different lengths. That I yes, I definitely So if my tulips have different lengths, that would make my would that impact space or time complexity is or both because despite even because if I think about like the big O notation overall, I'm thinking about where's complexity. So despite both of them having different length, I'm thinking about which one will be the one that holds the heaviest weight. And the one that would hold the heaviest weight would be the dictionary. So that's why I was basing off of my time and my space based off of the dictionary for the time complex or for analyzing space and time. My dictionary is shorter. Is that what you're saying? Oh, I see. Because the reason why the n only applies to the first one because we're looking at each element. But the reason why dictionary here doesn't matter is because when you look into a dictionary for the look in the dictionary, it is constant because it goes directly to this specific key and grab that value. So that is a constant operation, right? Is that what you're implying there, Ghost Magic? Within the dictionary key, correct? Well, because the dictionary is my understanding of it. Yeah, your lookup, your delete, your insert, everything's all of one. So constant. Sorry, just go and grab some water quick. For this specific example, it will only be two elements because for this specific, for it will always just be two elements, the odd one and everything else is the majority. So I will always just store two elements in dictionary. Other examples, based off the other examples, it will always just be two elements. The majority, which here is one, and it's going to be two, the odd one. So it will always be the majority and then the odd one. So we will always just store two elements in the dictionary. So yeah, and based off of this, it's like based off of this description or this statement here, all of them are the same except one number. So we will always just have two elements that get stored in the dictionary. So then all of them for yes. So then yes. Okay. So then I I take back my word. It's not O of 2n. So it will only be O of n because the heaviest weight will always be the list. N integers or n. The time is O of n for n amount of n amount in list to traverse through. I'm still trying to work on my time and space complexity. I want to make sure I word it and state it correctly. N amount of lists. N O, it stands for O of n for n amount in list to traverse through, and space is yes. working on that. So feel free to let me know what how you approach it and how I can do better with it too as well. Yeah. Alright, so I'm just trying to think about any other way I could write this. And I know that I can definitely use counter from collections, but I want to stick with the dictionary because I definitely want to work on my dictionary skills and levels and understanding of it. So I am going to keep it as is for the moment. Add it in stray. Okay, let's see. No, I definitely was overcomplicating it then. Because for X amount, if R dot count, that's right, I could definitely have used R dot count. Because yeah, that's a list method that will count for me. So now you can think how to exit it. If you only have 2 values in the dictionary, no, I'm thinking about that ghost magic because if I only let me where is my I want to go back to I passed all let me use it here. I can go ahead and use it here. Okay, so I am just trying to think about how I can exit early if you only have 2 values in a dictionary. But if we're thinking about dictionary, let me comment this out because I want to play with print stray of 3 3 3 3 and a 2. So it's gonna be add. It doesn't like this one. I'm gonna comment that out too. Okay, so let's go ahead and play with this. So I'm trying to think about like how to exit early, but I am just not. I'm just trying to think about how to exit early. Like, okay, I think, feel free to correct me if I'm wrong too, Ghost Magic. I think we agree that this isn't a good use case for what we're talking about on how to exit early. But if we want to go ahead and exit early, let's go ahead and do an example like this. And I just want to make sure it's an odd amount. 1, 2, 3, 4, 5. Okay, perfect. Okay, I hope this is a good example to showcase what I'm thinking and what you're thinking too. So okay, perfect. Okay, so we're kind of yes. Okay, the way I would do it is that if when I'm traversing traverse through, I would keep track of the num I seen. If you are a new number, that I know automatically, if you are a new number, I know you're the odd one out. You are odd one out. Because if we're talking about just this example, we know that we're only dealing with 2 elements. So we only know that we're dealing with 2 elements. So automatically, I can just be like, if the num does not equal if the num does not equal the previous num, then we can go ahead and exit early, is what I would definitely say. If you're a new number, you are odd one out and return the num. Return the num we are looking at. So then, yeah, so for this example, I would say something to the line of, I hate these. let's start, because I want to make sure I'm not going out of loop. Yes. In my, so I hope my pseudocode made sense to you. Yeah, because I've done these before and have gone I've gone out of bounds before. So I want to make sure I state it right. And I know, because I was gonna say for sure. Okay, so for sure I am thinking of an I and a J, and preferably. But if we want to exit early, but I was gonna say that I was gonna start at the end and work backwards. But if we're gonna talk about this one, I want to say I and J. I would say does J look like the number 4? If it does, both I and J increment, and then J is gonna say, hey, J and I, are you equal to the same number? And you're not. So then I would, J and I are not equal to the same number. So J and I are not equal to the same number. But then my question is, how do I know to return J or I? J or I. Okay, well, okay. Maybe I need to introduce a max value. I was gonna say a max value if J and I is equal to this, or no, because I was gonna say I and J, but then yeah, I got stuck onto where would I bring J and I to come in? How would I know to return J or I? That's why I want to go ahead and introduce a max value. And max value is always going to be equal to the first number. Equal first number. Straight of 0. But can I even initialize something to a max? No, I was thinking I could use the max function because I can use the max function on an iterable, and a list is an iterable, and I was thinking if I can use a max, but then it's almost like using the min function like this, min of the list, and then you have to do a key. I wonder why you have to add that part in. But yes. Okay, so what I would do, okay, let me just make sure, yeah, I can definitely use this as a play. Okay, print straight, okay, let me comment out my previous code. I would say for num, well, I wouldn't say num, because I want the index in the J to move. Do I want to say left right? I wouldn't say left right. I is equal to 0. J is equal to 0. No, because that would be O of n squared. Because I was gonna say, let me just write it out. Let me work through it. So I've been just thinking a lot. Okay, so for IDX in range of len of R, so this is gonna start at 0, and then we're gonna say that for J in range of, no, I wouldn't even say all the way to the length of R, because then J is going to reach the end of the list. I won't reach into it yet. I won't reach to it. So I have to go up until -1. J can go all the way to the end. Oops. -1. this one will actually be r minus 2 because it would stop right here. J's already reached the end, so I want to make sure I'm not out of bounds like that. Then I'm gonna say that I am gonna say that with one loop. The way I would do it with one loop is I would start at 1 and I would keep going all the way to the end. I would say that if the num of the idx is equal to the num of idx before it, or what I would say, it's even better if it does not equal the one before. idx minus 1. idx minus 1, because I want to say idx goes back by 1. Because I'm trying to say that I is going to, technically, yeah, so idx is going to start at 1. So this will be like our j. Let me rephrase this, idx. And then, so I want to say that, hey, you are idx minus 1. I want you to look to see if you are, sorry, not num. I was like, why is num being like that? Okay, if you are not the previous number, then we're just going to return. Now, the question is, do I want to return the idx or idx minus 1? Well, if you're already on the 3, if you don't equal each other, I'm just going to return the current one. That's what I'm going to do. Let me see if I get an error in Python June 25. 2. Okay, so it does return me a 2. I want to see if there's another. I'm gonna try to see if I can break it. So 2, 3. Okay. But what if I start in the beginning? Okay, so this one would not be correct. So, because we want to start here, and we want to like in the previous way. Is this what you're thinking at all, Ghost Magic? Let me know what your thoughts are. Yeah, no, feel free to let me know. Like, yeah, because I would love to go ahead and, yeah, try to get to this. So let me know what your thoughts are. If you were thinking the same thing, if you're thinking something different as well. This is what I was thinking, but, yeah, let me know. You need to iterate to the third one to be correct. Yes. In the other example, yep. You have to iterate up to the third, correct. Yeah, that's what I was definitely thinking. Yeah, I need to iterate up to the third, but I need to keep track of the previous ones I've seen before I knock it up. Because what if 2 was the first element? Yes. So That's so like yeah. So if I have to go all the way to the third one, wouldn't I still need a dictionary to keep track of it? That would definitely be creating the dictionary and memory, but then it helps keeps track of the counts I've seen thus far. So yeah, there. But were you at in your solution? Were you thinking about bringing forth a dictionary as well? Let's do another one. Yes. Okay. Or two variables. When you say two variables, like I don't know why, but my mind went to like thinking about left and right. But I don't think that's what you meant by two variables. You probably want to hold two variables as in to hold the two places to keep track of the ones you previously seen. Is that what you're indicating by the two variables? But let's do a 6. Let's level it up. Two variables. So you can replace your dictionary with A and B. Oops. So I have my dictionary. In dictionary, so we can say you can replace your dictionary with A and B. A is what I'm currently seeing right now. B is if something's different. Is that what you're saying? Would A equal the first element that I see in the list? Is that what you're saying? A and B are storing two numbers. C and D are storing count of A and B. But how would you know? I'm just curious for your example there. For example, A and B, how would you know to store what kind of numbers in there? Because as of we know right now, if we didn't see the input, how would you know um, the different type of numbers that are in there? Yes, yes, Ghost Magic. But that's one thing I love about algorithms is like there are different ways to attack or yeah, different ways to solve these problems. So no, I love that you're brainstorming with it. It kind of makes me think about stuff too. So let's do a 6 together. What is your programming language, by the way? Are you Python too or JavaScript? Let me know. Okay. Yep. Okay, so we're gonna put A to be the first value. How did I go back to my terminal? Okay. So A is equal to R0. Then how will we update B? I'm kind of curious. So essentially B would be like in Python world it would be like null, or in JavaScript world it would be null, but then in Python world I don't think we have a null, we have like a none. So B is going to be set to nothing right now, and we're going to say that for the IDX in range, well I would probably just say couldn't we do Oh, you don't even have to store B, but B will come along later on. Is that what you're saying? Because you would say something like, for num in R. Wait, be right back. Okay. And the way you would store it is you would say none, correct? Yeah, in Python world, it would be none. Python doesn't have a null. So we're gonna say for num in range. I wouldn't even say num. I would say index in range of 1. Because if we already stored the first value, we can just start at the second value then. And then we can go all the way up till the end of the array. And then we're going to say that if R of idx does not equal A, then B is equal to the R of the idx. Then we would just return B. Is that what you're thinking? Like that? Okay, let's let's run it to see if we get to our 2. I see. Okay. No, I am curious because I wonder if anybody else was thinking the same way you were. If this one does not equal that, if the first value is equal to the second value, then keep iterating through the rest of the array. If you don't, really? Wait, 3, 3. My terminal is this one. Because, yeah, I don't know if you can see it. Feel free to let me know. Now that I look at it, I'm like, my terminal is kind of small. But it seems like it still works for this example for 3, 2, 3, 3. Because, well, I was thinking it still makes sense because we start our index at 1. So in my head, it makes sense that case should work. But, because my concern is if always stating that it's going to return B. Because what if it could have been A, the first value? For 3, correct, yes, or 3, 2, 2, 2, yes. Because then that means we would have to return A then. Yeah, because they only gave back a 2. But then, because we kind of neglect the A. Because, yeah, I guess I can't always directly state that it's always going to return B. I wish you could say like a ternary option. Return B if this, else A. But, yeah, because we kind of neglect the A up here. I wonder, let me see, 6. Okay, it is. Okay. We return A on the third index. We can return A on the third index. 0, 1, 2, 3. Saying that because we can return A on the third index, that if we reach all of them, then we would just I was just trying to think, like, if we know that we reached to the end of the length of the array, then we know that all of the numbers, like for this example, we know that all of the numbers are the same, so then we know we can return A. But wouldn't that introduce another variable? Or, because, like, how would you keep track that each of the other numbers, if you start on 0, in 0, 1, 2. I mean, on index 2, if you start on 0. I mean, so you're saying that within this index right here, if we get to it and they're both the same number, then we can, I was gonna say, so you're saying that once we get to this index right here, we can automatically return the first first index, this first value right here, because we know that the numbers are the same. But what if our fourth index is the one number that is the odd one, though? So that's my only other example, because what if we do have another one? 2, 2, 2, 3, like that. So that's like that's why I was thinking. So, but Ghost Magic, let's do another one together. Let's do this 6 together. By the way, are you Python or are you JavaScript? Let me know what kind of language you do. Yeah, we would definitely have to keep iterating through it, so. Okay. What does it need us to do? So we're going to write a function called persistence that takes in a positive number and returns its multiplicative precision, which is the number of times you must multiply the digits in num until you reach a single digit. Ah, I see. Yeah, what programming language are you? So we're gonna receive an integer. We need to return three, because 1, 2, 3. Okay. Nice. Yeah, I've been wanting to get into some C# and Java for sure. I heard it's really good stuff because you get to know a little bit more about memory leakage and all that other stuff. So hopefully you get there one day. So yeah. Do you do algorithms for fun? Return. So we're gonna return back an integer. We're gonna return back an integer of the count of how many times to multiply the number until it becomes one number. So if so take for instance 39, this is not a single digit number, so we know that we can multiply each other. And this is 27, which is still not a single digit number, so we do 2 times 7, which is 14, which is still not a single digit number. 1 times 4, and now we get 4, so we have to multiply 1, 2, 3 times. That's why we would return back 3. Does this remind you of anything? Okay, let's see how I can do this. The way I think about this is it keeps multiplying itself. So in my head, I think about the fact that it's a recursion. It's going to keep calling itself until it gets to a single digit number. And how do you know that it's a single digit number? So with recursion, when we call itself, we're going to do base case. Base case is when we can exit the loop. When we can exit the loop if it's a single digit. The way to know it's a single digit if the length is 1. Otherwise, the recursive call is going to split the digits and multiply them together. This is, sorry, be right back. Okay, so this is what I'm gonna do. So let's write out our base case. If length of n is equal to 1, then we're just gonna return n. Otherwise, we're gonna recursively call persistence of n. I wouldn't even do n though, because if you take n, it's like 30. It's like a 39. You have to do other things to it. Persistence of n. The way I would do it before we get there is I would do n dot. I wouldn't do n dot split. I would do list of n. Print list, because this should give me a list of the integer, and now I can split it. And it's what I anticipate to see. Oh, okay, it doesn't let me. Okay, what I can say is that if the n, okay, what we can do is if n is greater than 10, because anything greater than less than 10, we know it's a single digit. Is not an interval. I've seen this before. I wanted to turn it into, essentially, I want to split the digits, because if you are 12, I want to turn you to do 1 times 2. And the way you can split it, I thought you can turn it into a list. I'm going to turn it into a list of a string of n. That way I can print out. That's my fault. I need to store it into a variable. List num, and now we should be able to print that out. Num. We will call this soon. Okay, perfect. Okay, so it does split it out like I wanted it to. But now I need to go ahead and convert it back into integers so they can multiply. So now we turn into a list of num. We need to say persistence of list of integer of list of num. And now we're gonna say int num is equal to list num for every integer. Hi Solaris, we are working on this one right here, and it's called persistence. And the way I'm gonna tackle it is doing it with recursion, because as you can see, it takes in a positive integer and it returns how many times it's been called to be multiplied. So we keep going until it's actually returning back only one digit. And this sounds like recursion because we're going to take each number, keep multiplying it, and now we're going to check to see if the number is actually just one digit. And we're going to keep doing that until it's actually returned back one digit. And we're going to keep track of the count. That's right, keep track of count. So it sounds like recursion will be involved. So I'm going to say count is 0. So now I want to modify it. So the base case when we can go ahead and exit the recursion is that if we know that n is less than 10, that means we know that it's a single digit and we can exit the loop. So otherwise, what we're going to do is we're going to recursively call it. Yeah, I haven't really written out the rest of the code yet. A while loop? Let me think about that. Could you elaborate a little bit more by what you mean by with the while loop? I don't know if I would use a while loop just yet. But I'd love to know your like thought process behind of why of using a while loop. I'd love to know. We're going to do list num is equal to list. But now we're going to take each integer num times for every integer num times equal next number number is equal to the next number of number. While number is greater than 10, could you elaborate more on how you got to the next number? On how you got next number? Because wouldn't you still have to break down the integers into a list of strings and then work with that? Yeah, I wonder if I am over contemplating it too. Count is equal to 0. And then we're going to say that if n is less than 10, we're going to return count. Sorry, that's my fault. We're going to return count. We're not going to return n. We know that the number is less than 10, so we know it's a single digit, so we're just going to return our count. Otherwise, we are going to go ahead. Something, I'm not sure yet, but I feel like I want to go ahead and add count here. And now when I call n again with a num, we're going to say count plus 1. So this one will keep calling that function. And then it will increment the count because we know that we have to do another iteration. So we're counting this iteration, and let's go ahead and break it down again. And now we're going to say that for num in list num, we're going to say num times equal, we're going to say total, we're going to total is equal to 1, total times equal num. Otherwise, it's going to keep going. He cannot multiply by a string. Sorry for that. string and integer is not supported between instances of string and integer. String and integer. It's not supported by string and integer. Because that's interesting, because I'm thinking n should have been an integer. So n should have been 10. That takes its positive parameter of num. I thought we were getting an input of an integer. What does the 3 asterisks in the front do? Yeah, curious to know. Total is equal to 1. Now we're going to say this. Total times equal each integer of num. Each integer of num. So you're saying number equal integer of each element for element in the string number. Despite it being a string number, I don't think it's a list. So I don't. Yeah, feel free to let me know what that star is. If n is less than 10, we're just going to return the count. We're going to say n is equal to 0, making sure that it's not indentation errors. And then we're going to say total is equal to 1. Trying to think, do I need to convert it into a list? If I have it into a string already, I think that should work, wouldn't it? Into string of n. Then now I'm going to say that we're going to convert it, and we're going to pass in our total. Oops. Yes, semicolon, of course, to activate that. Yes, I hope that makes sense. Okay, so we know that it's a single digit, and if it's less than 10, we know it's a single digit, and we're just going to return our count. Otherwise, we're going to start our total at 1. The reason why I start a total at 1 instead of 0 is because if you multiply anything by 0, you get 0. So the safest way to go is go ahead and use a 1. And we're going to go ahead and iterate through every single digit, multiply it, and then now we're just going to keep calling back, passing what we got into the function, and now it's going to check to see if it's going to hit the base case, or else it'll keep calling it and keep working it through. Time wise, let's see. So n is equal to string. Hey, here's your while loop. So Laris, you're saying count is equal to 0. You're going to say that while the length is still greater than 1, p is equal to 1. And for every integer in nums, you're going to multiply it, turn it back to a string, increment your count in key. Return the count. You could have done a reduce. I see. I see. Yeah, somehow I just went with the recursion call. Definitely a while loop would have worked. Yeah, no, I would never have guessed this one. Yeah, this one will take a while to definitely read. I see. Yeah, I hope you guys all had like a really good algorithm session. Let's definitely do more of these. So let's do it again soon. I'm gonna head out. So have a great rest of your Sunday. We'll all talk soon.